Hi everyone, this should be the last strace video, so this one will go into stracing Gitaly and understanding what's going on there. All right, so let's go ahead and get started. So I will first do a real quick request, and then we'll do a more difficult one, more complex. All right, so let's just strace Gitaly here. Same flags as always. Okay, kick that off, and we'll just pull up this repo, which is on our Gitaly server. So this particular Gitaly instance is remote, so it's not on the app server. It's on a separate host, which is connecting or communicating over TCP with the actual Rails node. So if you look here, let's just what I want to do is find a FindCommit, because that's a pretty quick and easy request. Okay, here we are. So FindCommit. So here we're reading in on port 8075. Here's our remote IP address. And so like we saw in the last video, here are the basic fields. This is actually, just like the request we saw on the other one, this is what we see on the other end of the wire, right? So here's the actual RPC we're calling. Here's our bearer token. Client name is GitLab Web because it was triggered by the browser. Here's our correlation ID, session ID, deadline type is regular. Here's our path to the storage, project number, project name, branch. Okay. All right. So we read that over the wire, then we check if there's anything else. Nothing comes back. So then what Gitaly will do is it'll start validating that these directories exist. So it'll say, does the base directory exist? What about the objects directory? And then we check if the refs directory, does the head exist? And packed refs, which may or may not exist. Typically they will. Okay. So that's the first thing we always do whenever an RPC comes in, is we just kind of validate these directories exist in those files. But because Gitaly is written in Go, and it's Go will typically have, I think, 8 threads per process. You're going to see what happens is that what process or PID in strace is doing the work jumps around a lot, and so it can be hard to follow. Okay, all right. So 8623 is our PID. So you can see that it does that. It creates a pipe, which I think is going to use to communicate with the Git process. And it creates an epoll to wait on something, I guess the pipe, yeah. And then it creates a few more pipes, presumably for standard, or another one, that's gonna be for standard error, I guess. Or actually it creates 3, standard in, out, and error, yeah, all right, that makes sense. Okay, then down here, it gets its PID. So this is the actual PID that you'll see in PS, is 14355. And this just happens to be thread 8623 that's doing the work here. All right, so then 8623 clones. So let's actually go to the end of that first. And you can see that it comes back with, in this case, it's creating a new process because we don't have the clone _ thread flag in here. And also this clone vfork, which is a good sign that it's a new process. And so anyway, so here's the process number we get back. You can actually see that 27634. You can actually see that here. It starts up before the clone finishes, right? So the clone can't actually get return with the process ID until the new process is actually spun up. So let's just look at the new process now, 27634. All right, so because it was cloned, it does the RTC action where it sets all of its signal handlers. So you can see a big block of those right at the start. So like I mentioned in the earlier videos, that's a good way to tell that you've got a new process coming up. And here it's setting up its standard in, and then standard out, and then standard error. So it's taking these pipes that it got from its parent process and using them to create its input and output pipes. And then at that point, it then execs Git. Here's the Git directory that we're using, and we're doing a cat file batch. So cat file batch will let you pass in refs, and you'll get back the actual contents of that file or blob. Okay, or commit, which I guess FindCommit is probably going to return a commit, isn't it? Okay, and then at this point we're doing what we saw in the Git video. We check where our heap ends. And you start loading our shared library. So I'm just going to skip past all that since we have seen all this in detail previously. Load our Git configs, and here we start loading in the Git directories. Skip past all that. And this should be pretty quick, just because basically Git's going to do almost no work here. We're just going to get a single commit back. Yeah, okay. So here, we write out that we got a commit, and then here are the details of the commit. And then we get in, here's another commit to print. And so we print out details of that as well. Yeah, no, okay. Actually, we write that out, and then we write out this, which is, okay, yeah, all right. So this, what happens here is, so we write out this output, that goes to Gitaly. Let's actually look at that in more detail here. All right, so we write out our standard out. Here is the SHA, and here are the details. And then 8623, which somewhat surprisingly was the process that forked all this in the first place, is the one that picks that up. So it reads it off. You can see it's a big chunk of data here. And then here it writes out OK to FindCommit. So we've actually finished at that point. That's a little interesting. Actually, that makes sense. Yeah, okay. All right, so then what are we actually putting in the body of the response here? Yeah, here it is. So here's the body of the response. And you can see it's just encoded the data that we got back from Git. So that's FindCommit. That's quick and easy. Basically, we just have this gRPC level over Git. So it comes in, Gitaly forks a new Git process. Git then does exactly what you saw with the local Git, pipes that back out to Gitaly. Gitaly then does some minor transforms on it and sends it back over the wire out to GitLab. Not too complex. Once you know what Git is doing, and pretty easy to follow. All right, so that was the easy one. Let me actually parser this. Where'd it go? There it is. Oops. Okay, great. All right, so let's strace Gitaly again. And this time what we're going to do is we are going to make a change via the web UI, and we'll see what that looks like. Okay. So strace Gitaly. Okay, that's done. And let's actually take a look now. What we'll do first is we'll that's a little easier. Okay. Here we are. Okay. So just to give you a quick idea of the structure of a request before we dig into the details in strace. So this is a GitalyRuby request. So a Gitaly normal Gitaly worker is going to take the request and it's going to write it over a socket to Gitaly-Ruby, which is a Ruby process, as you might have guessed, which is multi-threaded. And so it'll have one listener thread, which will then pass it on to a worker thread. And then we'll kind of do 3 steps. We'll run our pre-receive hooks, we'll do the actual commit, and then we'll do the post-receive hooks. So you can kind of see that this is the structure of how it works. So these PID IDs or PIDs in brackets are threads. Ones without brackets are full processes. So this is the 14445 is the GitalyRuby worker that gets the request. It then launches the pre-receive hooks, which does some work, and then we'll write out to. Then we also do the update ref. We're going to update head there, I guess. Yeah, and here we are. Yeah, all right. Here we're updating the ref with git. And then we're doing post receive. I'm not seeing. Well, we'll see that. We'll go find that when it gets to it. Anyways, that's the basic overview of what we're going to do. We're going to run pre-receive hooks. We're going to update the ref. We're going to do post-receive hooks. And we're going to see the same basic pattern, particularly with pre-receive and post-receive hooks, of what happens. So let's actually dig into the Strace itself and see what happens here. All right. So this was UserCommitFile was the RPC we called. All right. So here is the main Gitaly process, reading that off the wire. Port 8075. UserCommitFiles. We can probably see blah blah in here somewhere, maybe. No, I guess not. Here's the actual details of the push. Okay. So first thing to go into is as of 12.10, Gitaly will cache the refs for a given project to make it more efficient to respond to HTTP requests. And so whenever a request comes in that modifies the refs for the project, so like making a push or a commit, we need to update that cache. So the first thing we do is we delete the latest file here. So we use unlink@, to delete that. And you can see it's in this the basic repository directory, and then plus Gitaly, the state, then hashed, and then so on from there. So basically, we're saying the cache state that we had there is no longer valid, and we're deleting all these files. And then from there, we can go into the standard new fstat@ that we saw earlier. Actually, no, this is still for the cache. Okay, so we validate that these directories exist. Then we start making that directory tree again. Although in this case, I think they already existed, so we shouldn't do too much work there. All right, and then we created this new file here. Okay, yeah, all right, now here, so we kind of created this. This is going to be the pending refs change. So we're not going to commit that until after everything's done, though. So that just kind of hangs out there until we're done with everything else. Okay, we close out that file handle. And now we can start doing the new fstat that we saw at the start of the FindCommit request. So we validate all the trees are there. And then here, we're actually writing out, is this the same PID? Yeah, it is, okay. Yeah, okay, we write out to the Rails client here, I guess just acknowledging the response. I guess we do that after we've cleared the cache. And now here, we're writing over a Unix socket, which is going to be going to GitalyRuby. And you can see down here, for whatever reason, Strace doesn't capture what the path of that file is from the sender, but you can see down here that this is, in fact, ruby1.socket. So this is GitalyRuby worker 1. It's getting the message back, or getting the message over that socket from the main Gitaly Go process. And so you can see it's add new file, here's the server details, and so on. So you can just same basic content that we saw above. All right, so 14426 reads that in, but it doesn't actually do the work. It just just reads that socket, and then we pass it over like we saw in the parser output over to 14445. And there's no explicit syscall here because it's all within the same process. So you just kind of have to watch for what process or what PID here starts getting active. So based on between the parser and just seeing 1445 start working, we know that's the next one to actually begin work. Okay, so 1445 is going to do most of the work, I believe. Yeah, so let's just narrow that down. Okay, and so what's the first thing it does? It's writing this out. Oh, that's for an epoll. Okay, we can ignore that. Okay, we create a new socket, and then we are connecting on port 8075 to Gitaly itself. So basically what happens here, and this is a really common point of failure, something to be aware of, is that this GitalyRuby request in particular needs to call into the main Gitaly process before, as part of the collecting the data it needs to actually go out and do the request. So the first thing it does is connect to the main Gitaly process using the address set in the Rails server config, right? So that's passed as part of the header in gRPC. So that's how it knows how to connect to the Gitaly server. Now, keep in mind that if we had multiple Gitaly servers, we might be connecting to an entirely different one for whatever reason, if it was a fork, for example. So in this case, it's the same server because we only have one. But if Gitaly is not able to connect to itself, then you're just going to get a really generic error, which is not common, but really hard to figure out when it happens. Okay, so we are trying to connect over UDP for some reason. First, that fails because we're not listening on UDP, and we try again with IPv6 TCP, and that does connect eventually. We saw most of this pattern in the Puma video, so I won't go over it in too much detail. And we send a message, and we actually see the RPC here. It's not obvious what the RPC is. Okay, here we are. Yeah, so it has local branches is one. And if you look at the source code, you can see all this. But frankly, the GitalyRuby source code is kind of convoluted. So it's often easier just to look at Strace to see what we're doing. Okay, so we've done that. Then we check if a ref exists. We just create a new connection again. And at this point, we've gotten the data we need from the main Gitaly process, and GitalyRuby starts opening up the repo data itself. So it starts setting the Git depository or repository path. So instead of using Git here, we're using Rugged, which is Ruby bindings to libgit2, which is a C library that basically works like Git, but is not actually Git proper. We use both in GitLab. But you can see it's the same basic process. We make sure the directory exists, and we read the configs. It's, libgit2 is supposed to be entirely in feature parity with regular Git. Okay, so we read our configs. We're reading our packed refs here. Okay, well, actually, we're still going out to main Gitaly process again. Okay. So I'll skip over most of this because this is what we've seen previously. Okay. All right. So we've gotten to this point where we are writing out a temp object. So here we have our temp file name like we saw earlier. We make a directory. We write that, or write to the temp object, or write some more of the temp object. Fair amount of data there. We fsync here to make sure the change goes through. I don't think we said that was the local Git. That's something you can set in your config, and by default, GitLab does turn that on, which is good. Helps prevent data loss. Okay, then we rename the temp object to the real name. We've seen all this before. All right, let's just skip ahead a bit, because this is a pretty long request. Okay, so we closed our object, but we haven't actually committed anything yet. And here's where we start firing off the forks. So here you can see we see Ruby calling vfork, and we get PID 28271. So here's 28271. It takes its signal handlers, changes its directory to the repo directory, and here we exec the pre-receive hooks. And then immediately we start cloning. Here you see the clone thread field or flag being passed, so we know that this is not actually a new process, it's a thread for that process. All right. And then we're writing out, this is GitalyRuby process writing to the pre-receive hooks. Here's the old ref, a new ref, and here's the ref that we're changing. Okay, load in our shared libraries. I think this is just a shell script. We could look at it, but I'm lazy. Yeah, all right. Let me start opening up the hooks here. Maybe this might have changed recently, actually, now that I think about it. I think we switched over to Go. But it was breaking things, so we may still be in Ruby. Okay, we're still doing some setup here. Have we cloned a new process? It's 22871. We're just changing our, I bet we had exec feed here, didn't we? Yeah, okay. Okay, we got another thread. Here we're opening up the Gitaly hooks log. Getting our locale. Let's just go down to 28271 for now. Okay. Here we're writing it to the Gitaly internal socket. This is new, I think. Yeah, we haven't actually put anything there. Okay. So here, this is presumably the main Gitaly process reading on this internal socket. We're writing out a short message. This looks interesting. Okay, here we are. So now we are execing the pre-receive hooks in GitLab shell. Just as a reminder. So yeah, so here's 14445. Here we launch the Gitaly hooks, which in turn launches the GitLab shell. Actually, it's pre-receive. Where's GitLab shell? Oh, is this the one that does 2? It might be. No, GitalyRuby, GitLab shell hooks pre-receive. Okay. Oh yeah, okay, it's doing base name here. Just to get this, okay. Yeah, okay, actually here we see that, but not there. All right, anyway, let's get back to the business end. Okay, so we launch a pre-receive hook. those inner shared libraries, standard preamble, read proc. Okay. Here we start. Yeah, all right, this is a Ruby process, so we can see it loading in all these shared libraries. Actually, we haven't gotten to the gems yet. Okay. All right, just looking here to see if we have any other pre-receive hooks to run. So if I had a custom hook, then this is the point where we start triggering them. I don't have any on this particular host, so we just keep going. And so here you can see the kind of the standard pattern for Ruby when it's first loading up a library is it will need to go in and load each of those files at runtime. And it'll kind of walk the tree, and so you'll see a ton of ent calls or responses here. That is normal for that to happen when a library is being loaded. That's just the way Ruby works. So it looks bad, and that's the Ruby way, but it's not unexpected with Ruby. Okay, so there's going to be a lot of this. Well, we keep loading lots and lots and lots of Ruby files here. Just going to skip down. Oh, okay, here we're loading in the cert bundle that we bundle with GitLab. So all the certs that we trust by default. Loading OpenSSL, HTTP helpers. Right, and here we go. All right, so at this point, the pre-receive hooks, this is another common point of failure, is they make a call out to the internal API, the internal allowed endpoint to say, this is what I've got, am I allowed to do this? And then we have to wait for Rails to get that request and respond back to confirm that the user and this change is allowed. So in this case, we get a response back pretty quickly, but it's not unusual. I mean not unusual is the wrong word, but it's not unheard of for that to take a long time or to error out. So that's another common place that this request can fail. Okay, but in this case, it works. Let's go down. Yep, so then we log out to the GitLab shell log that everything's okay. They were actually sending another request. Yeah, okay, then we call the internal pre-receive endpoint. And we log that's okay as well. Okay, and then the pre-receive hook exits. Okay, so that was 28278. So we've run the pre-receive hook. We still have to do the post-receive hook and the update. Okay. Yeah, so this is actually, I think, brand new with 13.2. We do this in Go. This used to be all in Ruby. Things keep changing. All right. So here, all the pre-receive hook clusters are exiting, and you can see that the Ruby worker gets the sig child that's children have exited. So then it wakes up and starts doing the next job, which is the update hook. So now we've done the pre-receive hook. Now we need to do the update. It's going to be the same basic pattern. Right up to the internal socket. Have we forked here? Here it is. We v-forked. And looks like 28285 is the new. Yeah, okay. So here we do the Gitaly hooks update. Set our signal handlers, our libraries. Create our thread. I think we are waiting. Okay, let's see what the thread's doing here as well. Okay. Yeah, so then we write out sending another RPC to the main Gitaly process over internal sockets. So it's kind of confusing that we're both using the external and internal connections for Gitaly here, depending on what we're doing. That's, like I said, that's new. So we're seeing this for the first time. Okay, so we read off the socket, and then we're going to see this time the hooks and go do the task. Okay. So 14361, actually 28294. Yeah, okay. So here again, we see the hooks. Yep, and there we are. We're executing that. Here are the args. We're updating the master branch, old ref, new ref. Okay, great. Load in our many Ruby string files. I'm going to see the same things last time. We shouldn't need to go out the network though. Come on. There we go. Okay. All right. So we're reading our GitLab shell config. We seem to have done nothing. Yeah, let's just get by something. Let's just stop filtering. The child exiting. Where did it do its work? Yeah, so here we're checking if there are any update hooks, which there are not. Okay. Must be missing something here. Anyway, so we can see that it did work. And then we're actually even trying to kill that file or process even though it already exited. Let's go up a little bit. This is bothering me. It seems to be loading in Ruby files. Okay, well, this video is already long, so let's move on. I don't want to take all day. All right. Yeah, all right. So here we are. Here we're doing get update ref. I'm going to read the question from standard in, read in all the shared libraries. And then the standard right to the head.lock and then rename and unlink like we saw in the other video. All right, so we've updated head. So now we've actually committed the change to the new blob in Git. So as far as Git's concerned, we've actually made the change. So now we just need to run our post receive hooks. And so you can see, once again, 1445 picks up again and starts doing some work. And fork yet another process, and here we have post receive hooks. And so once again, it'll be the same pattern. We get the base name for that. I think we're going to exec v that here. Yeah, here we are. All right, so we do Gitaly hooks post receive. Work our new process. At some point, we're going to write it to internal socket, I guess. Here we are. Okay. So we write that. Work our new processes yet again. Okay, and at this point, I don't think that a failure would cause anything to roll back. So I don't actually have any post-receive hooks in here, so it should be just loading up Ruby and then exiting like you'd expect. Just scroll through this wall of text. Oh, actually, we're making an external call. Okay. And there's no other traffic on this instance, which helps keep the noise down. So if this was an strace from a production instance, you'd see all kinds of traffic coming through, which would make it much harder to follow what's going where. Oh, well, we're going to call the internal post-receive endpoint, aren't we? Okay. Well, let's find out. Okay, here we are. Yeah, so then we call into the internal API for the third time in this call. This time we call post-receive to fire off all the post-receive actions, which would be like creating a new merge request and stuff like that. Then that's successful quite quickly. Exit. Go returns back to GitalyRuby that the post-receive hook was successful. We exit our many processes and threads. We wake up the Ruby worker yet again, and now we should be basically done. Okay, yeah, let's go down to that. Yeah, all right. So we wake up and then we write out to the review one socket again, back to the main Gitaly process that we're done. And I guess this is our new ref here. Okay. So if we look at that, let me pull it up again. All right, let's just go to this. Okay, so I write that out. Let's just come back. Here, the main Gitaly process reads it. Then down here, we write it out over TCP, and we're still sending post-receive hook there. When are we going to get the user commit file again? Somewhere in here. Oh, right, yeah. So we still need to do the cache again. Okay, so at this point, we've done our mutation to the repository. Now we need to update our cache. So that's what's going to happen here, is that we go in and create the new REST file, write to it, and then we log that we updated the cache successfully. And then here we log that the actual user commits file itself was also done and took a little over a second. And that's with strace running, still everything down. And then we log something more about the disk cache. But okay, yeah, so that is user commit files. That's one of the most complex RPCs we have. Just to recap, so to Gitaly, then to GitalyRuby. GitalyRuby then goes to Gitaly again several times. Then it loads the repo itself internally. Then it launches pre-receive hooks to go back to Gitaly, which then go out to the Rails application, which come back to GitalyRuby. Then we do the update, and then we do the post-receive hooks, and then we go out to Rails again. Yeah, so we're just all over the place, and at any point, if any of those connections break, the entire thing falls over. So that is something to be aware of. Okay, so that is Gitaly and Strace. Great. Hopefully this was useful and interesting. Thanks for watching. Take it easy.